When talking about resonance, you want to understand the resonance contribution to the hybrid structure. Basically, we're asking which resonance structure does the hybrid look most like, or which resonance structure is more important is another way to say it. So here are three main guiding principles, for the most part in order of importance. Number one, structures that minimize charges are more important. So if we look at our first example, this illustrates number one. So in the first resonance structure, there's two charges within it. But if we move these electrons, we can get a second resonance structure that doesn't have any charges. So this is the more important resonance structure, or the major contributor. Number two, structures where all atoms have an octet are more important. So in number two, if you look at the first structure, we see that the carbon right here lacks an octet because it's a carbocation. It only has 6 electrons. But what we can do with resonance is use the lone pair on the neighboring atom, push that down, and we get this structure right here. That fulfilled carbon's octet, and then the oxygen, it still has one lone pair, and even though it has a positive charge, it has an octet. All atoms have an octet here. So that makes this structure more important. And then finally, number three, structures that place a negative charge on the more electronegative atom are more important. So here's an example of number three. The first resonance structure, the negative charge is on a carbon. But if we delocalize that, we can put the negative charge on the oxygen, and that makes this structure the major contributor to the resonance hybrid.